Hello my dear students, it's my pleasure to meet you again today. Today inshallah we are going to study a new lesson, which is algebraic lesson. We will study about introduction in complex numbers. Okay, we are going to study about imaginary number. It's the first time to listen about imaginary number. We call it I. So concentrate with me to know what is I and what is the need of it. If we concentrate with us, we have here solve in R. If we want to solve an equation like that, x power 2 equals -1. Okay, if we have x power 2 equal -1 and we want to solve this equation, we will find the square root of left side and right side. So square root of x power 2 equal positive or negative, as we know, square root -1. But unfortunately, square root -1 doesn't belong to R. It is not a real number. So we have here x equal positive or negative square root -1, and we need for something to solve this problem. So we have a definition about something called I power 2 equals -1. Okay, and we call I the imaginary number. So we here put, instead of -1, we will put I power 2. And of course, it will be benefit to us to find the square root of I power 2. It will be x equal positive or negative I. Look carefully to this definition. I power 2 equals -1. So the square root of I power 2 equals I. So here the solution set of this equation is x equal positive or negative I, but this solution doesn't belong to R, but it is belong to positive or negative I. It's belong to something called set of complex numbers. And what is the complex numbers? Complex numbers, the set of complex numbers, we can define it as a set of A plus BI, and A and B belongs to R, and I power 2 equals -1, and this is the complex numbers. And real numbers is a subset of complex numbers. Okay, we know that that A is a real number, B itself is a real number, but BI is an imaginary number. Imaginary number. Okay, let's move quickly to dive in I. What is I again? The definition is I power 2 equals -1. And if we have I power 2 equal -1, so what about I power 3, I power 4, I power 100, I power 101, and so on? So let's concentrate here. We have I power 2 as a definition equals -1. What about I power 3? We know I power 3 means I power 2 multiplied by I. So -1 multiplied by I, so it's -I. Okay, so I power 3 equal -I, and you can keep it in mind. It's easy for you. What about I? I itself, I. No problem about it. What about I power 4? I power 4, it's I power 2 multiplied by I power 2. I power 2 equal -1 multiplied by I power 2 equal -1 also. -1 multiplied by -1 equals 1. So now we have I power 4 equals 1. What about I power 5? I power 5 means I power 4 multiplied by I. Why we talk about I power 4? We have here I power 4 equals 1. So I power 5 equals I power 4 multiplied by I power 1. So it's 1 multiplied by I. So it's I. What about I power 6? I power 6 equals I power 4 multiplied by I power 2. I power 4 is 1. I power 2 is negative 1. So it's negative 1. What about I power 7? I power 7 equals I power 4 multiplied by I power 3 equals 1 multiplied by I power 3, which is negative 1, negative I, because we have I power 3 equal I power 2 multiplied by I, 1 multiplied by negative 1 multiplied by I, so it's negative I. Okay, what about I power 8? I power 8, we have I power 4 multiplied by I power 4, so it's 1 multiplied by 1 equals 1. What about I power 12? I power 12 equal I power 4 multiplied I power 4 multiplied by I power 4 equals 1 multiplied by 1 multiplied by 1 equal 1. So concentrate with me, my dear students, that if we have I power 4n, it is equal 1 because it is a multiple of 4. What about I power 4n plus 1? I power 4n, it's 1, but I power 1 equals I. Okay, let's move something about solution of some equations in C, which is the set of complex numbers. Solve in C the solution, the equation x power 2 plus 4 equals 0. If you want to solve in C, as we said, it is a set of complex numbers, and x power 2 here, we can move 4 to be negative 4 in the other side. So to find solution set of this equation, we put x square root of x power 2, and it is positive or negative square root of 4, sorry. And negative 4 doesn't belong to R, but now we have x equals square root negative 1 multiplied by 4. X equal negative 1 is I power 2 multiplied by 4. So x equals 2I, positive or negative, of course, positive or negative, don't forget it, positive or negative 2I. So solution set equals 2I and negative 2I. And pay attention to something is very important, that 2I and negative 2I are conjugate. What about conjugate numbers? We know about a plus bi, it is a complex number, and look forward, a minus bi, it is another complex number, but it is a conjugate to this number, and this number is conjugate to this one. So the two roots of the square number in C or in complex numbers must be two conjugate, one of them positive 2i and the other negative 2i. Someone asked me, what about a here? What about a here in this number? Look forward, it is 0 plus 2i, and the other number here, it is 0 minus 2i, because a here maybe belongs to or maybe equals 0. Okay, someone asked, is b also can be 0? if a plus bi is a complex number and b equals 0, it will be a plus 0, it is equal 0, sorry, it is b here is 0, so it is a plus 0, so it's equal a. A, we can say it's real number. Someone asked, can we say that a is a complex number? Yes, a also belongs to complex numbers, because at the end the real number set is a subset of the complex number set. So any real number, we can say about it, it belongs to complex number. Okay, let's move to another example for us. Let's move forward about I again. Why about I power a very large number, I power 1000 example. So if we have I power 1000 like that, what is it? We know 1000 is divisible by 4, so it is a multiple of 4, so it's 1. Yes, it's very easy. But I power 1001, it's I power 1000, which is already 1 multiplied by I, so it's I. What about I power 1002? It's I power 1000, which is a multiple of 4, so it's 1 multiplied by I power 2, which is negative 1, so 1 multiply negative 1 equal negative 1. What about I power 1003? It's of course I power 3, because I power 1000, as we said before, it's 1. And we know about I power 3 equal negative I. What about I power 1004? We know that 1004 is divisible by 4, so we have no remainder. The remainder here is 0, so it's 1. We can say I power 0 and it's 1. Okay, so my dear students, let's solve some examples also about I. Find the simplest form of I power 16. Yes, we know that I power 16 here is divisible by 4, so it's has no remainder, or the remainder is 0, so I power 0 equals 1. What about I power 63? We know if we divide 63 by 4, it will be equals 15, and we have the remainder equals 3. That means that I power 3 and I power 3 of course equals negative I. What about I power 42? I power 42, if divide 42 by 4, the answer will be 10, and we have remainder I power 2, it's negative 1. What about I power 4n plus 23? 4n plus 23. We know that I power 4n, it's 1 multiplied by I by 20 power 23, and we know that 20 is divisible by 4. The remainder is I power 3, so it's negative I. Okay, what about the negative power of I? If we have I power negative 1, I power negative 2, I power negative 3, I power negative 4, and so on. Let's go to I power even number is negative. So if we have I power negative 2, okay, this number means 1 over I power 2. Okay, it's very easy. So to have this I here in the denominator, we will simplify it by multiplying the numerator and denominator by 1. What about 1? 1 is I power 4. Okay, if we multiply it by I power 4 in this numerator only, it's multiplied by 1, so it's no problem about it. 1 over I power 2 multiplied by I power 4, it's I power 2, it's negative 1. And we know that I power 2 equal negative 1. So do not panic about the negative. If we have I power 2 equals negative 1 and I power negative 2 also equals negative 1. Okay, because we have here I power negative 2, we can say here I power negative 2 times I power 4, because I power 4 is 1, so we can multiply by it. Here I power 2 equals negative 1, so I power 2 it's negative 1, and also I power negative 2 equal negative 1. What about I power negative 4? We will deal with the even number only. I power negative 4. We know that if we multiply I power negative 4 by I power 4, it's no problem, because I power 4 is 1. Here it will be I power 0, so it's 1. So we can say new conclusion that I power negative 4 it's also equal 1, I power 4 it's also equal 1. Okay, I power 2 equal negative 1, I power negative 2 equals negative 1, I power 4 equal 1, and also I power negative 4 equal 1. So like power 2 and negative power 2, and also 4 is the like power negative 4. So what about I power negative 3? Of course we can multiply it by 1, which is I power 4. The answer here will be I power 1, and now it's I. So I power negative 3 equal I, but we know before that I power 3 equal negative I, and now I power negative 3 equals I. So it's opposite of the negative. Negative here will be positive, and you can converse I power 3 equal negative I, and I power negative 3 equals I. So find the opposite of the sign here. What about the I power negative 1? I power negative 1, of course we can multiply it by I power 4, which is 1, so it's I power 3, so it's negative I. And we can say a conclusion also about this, that I power 1 is I, but I power negative 1 is negative I. Okay, it's really easy for you, but you can practice it carefully. And we have some examples about solution of some equations in C, which is set of complex numbers. Let's revise again and again. We can revise about the numbers. We have studied before about natural numbers, integer numbers, which is Z, Q, which is rational numbers, Q dash, which is irrational numbers, and also real numbers. So let's concentrate here. We have here n. N is the set of rational numbers, which is 0, 1, 2, and so on. And the set of Z, which is integer number, is concluded. Z here means 0, 1, 2, and so on, and also negative 1, negative 2, and so on. We add negative for natural number to be Z, which is integer, set of integer numbers. And also we can maximize this set of numbers by something called Q. Q is a rational number. A rational number, it's any number can put in this form is a fraction, and b doesn't equal 0, and b belongs to z, of course. So we have a rational number, and we have maximize also these numbers, because we have q dash. Q dash here is the numbers that pi or square root 3, cubic root 4, and so on, and we maximize them by complex numbers. Complex numbers here is c. C is a plus bi. A and b are real numbers, but bi is imaginary part of this number. A itself belongs to r. This is an imaginary number. As what? As 2 plus 3i, 2 minus 3i, 5 plus I, 5 minus I, and so on. So natural is a subset of z, which is integer set of numbers. Z is a subset of q, which is rational number. Q union q dash equals the real number, and real numbers, set of real numbers, is a subset of C, which is complex numbers. And we talk about the definition of the complex numbers. It's in the form a plus bi. A is a real number, bi is an imaginary number, and b and a belongs to r, and the definition of I power 2 equals -1. So it is a complex, the set of complex numbers. Okay, let's move about something else, about solving equations and some properties about the complex numbers. What about the equality of two complex numbers, and how can we benefit from it to find a value of x or y? We have here an example. If we have x minus 3y plus 2y plus y multiplied by I, like that, equals 6 plus 5i. And the request is to find x and to find y also. So we know about a very important property, that x plus yi, if it is equal a plus bi, this is a complex number and this is another one. So it must be x here equals a, the real number equals the other real number, and y here it's equal b. Y here multiplied by I, which is imaginary number, equals bi. So y equals b, of course. So we will try to simplify this part to equal this part. So we have x here minus 3y plus 2y, 2yi here, because 2y multiplied by I equal 2yi, plus y multiplied by I also equals yi, of course, equals 6 plus 5i, which is the right hand side. We can add the real numbers which is with each other. Here we have x minus 3y plus 2y plus y. Here 2y plus y, we can say about it equals 3y, but sorry about something wrong here, it's x. So here it's x. Okay, so we can say 2x plus y multiplied by I equals 6 plus 5i. When we make equality like that, real number equals the real number, So x minus 3y will be equal the real number in the right hand side, which is 6, and we have the imaginary part 2x plus y here equals the imaginary part here, it's y, it's 5, and we can solve this equation with each other using some methods which we studied in third preparatory. If we put here 2x plus y equals 5, okay, we want to omit x or y here. To omit x or y, they must have the same number and different sign. Here is y and here is negative 3y, so we can multiply this equation by 3. So it will be 6x plus 3y equals 15. By adding this equation by this one here, negative 3y plus 3y equals 0, x plus 6x equals 7x, and 6 plus 15 equals 21. So x equals 21 divided by 7 equals 3. So okay, so x equals 3, and we will substitute about x equals 3 in any equation of them. So we have to multiply it by 3 plus y equals 5. So we have 6 plus y equals 5. So we have y equals 5 minus 6. So it's equal negative 1. So solution set here is y equal negative 1 and x equal 3. So we have solution set equals an ordered pair 3 and negative 1. Okay, my dear students, let us take some break and we will. Hello again, my dear students. It's my pleasure to return again with you. We will complete the complex numbers. It is the lesson of algebraic lesson, which is the introduction of complex numbers. So let's move to the operations of complex numbers. What is the operations of complex numbers? Of course, operations means multiply, divide, add, and subtract. So if we have a number like that, we have here operations on the complex numbers. If we have a number or a complex number like that, 3 plus 7i added to 5 minus 9i, how can we deal or add these two complex numbers? We have adding here, so it's plus. Now we have 3 its real part and 5 its real part also, so we can add them with each other. So 3 plus 5 equals 8, and also the imaginary part, which is 7i, and also the second imaginary part, which is negative 9i. 7i plus negative 9i equals negative 2i. So now we have the result, which is 8 minus 2i. Adding two complex numbers gives another complex number. We have another example. If we have 2 minus 4i subtracted or minus 5 minus I, we have here 2 minus 4i. We can release the bracket now. It's no need for bracket because there is no number here, so it's with bracket or with not, it's no problem about it. So negative multiplied by positive 5, it will be negative 5, and negative multiplied by negative equals positive I, and also we can add them. So 2 plus negative 5 equals negative 2, negative 3. This is the real part. And also negative 4i plus I or 1i equal negative 3i. So the answer is negative 3 minus 3i. We can move to example multiplied 4 plus 3i if multiplied by 2 minus 5i. We know that if we have two brackets multiply each other, we can put multiplied here. So 4 can multiplied by 2, and also 4 can multiplied by negative 5i. So 4 multiplied by 2 equal 8, and 4 multiplied by 2 negative 5i, it's negative 20i. Also means that 3i multiplied by 2 equal positive 6i, and 3i also multiplied by negative 5i equals negative 15i power 2. We have here this number I power 2 here. We know that I power 2 equals negative 1. So negative 1 multiply negative 15 equals positive 15 here. We have to simplify it. And we have 8. Negative 20i plus 6i. And we will add 8 to 15. Why 8 to 15? Because they are the real parts, which is 23. What about the imaginary parts? Negative 20i added to 6i, it will be negative 14i. So the number, the complex number now equal 23 minus 14i. Let's move to another example. If we have 5 to I multiplied by 5 plus 2i, someone, if he concentrates about these numbers, this number is they have converse of sign. It's minus 2i here, it's plus 2i here. So this number is the conjugate of this number, and this number is the conjugate of this number. So they are conjugates. Let's multiply. 5 multiplied 5 here will be 25. And if we multiplied 5 by 2i, it will be positive 10i. And if we multiply negative 2i multiplied by 5, it will be negative 10i. Negative 2i multiplied by 2i, it will be negative 4i power 2. And if you notice that here we have 10i minus negative minus 10i, so it's 0. And from your studying in the second preparatory, we know that if we have something like that, if we have x minus y multiplied by x plus y, we multiply x by x, it's x power 2, and also multiplied by negative y by y, it's negative y power 2, and it's enough, because we know that the middle term like this equals 0, and we call them we call it difference of two squares. Okay, so if we have two complex numbers like that, one of them is the conjugate of the other, we can multiply the first by first and the second by second only. We needed to multiply 5 by all of this bracket and negative 2i by the all of this bracket. So if we have 3 plus 5i multiplied by 3 plus minus 5i, and we notice that they are conjugate of each other, so we can multiply 3 by 3, it's 9, and multiply 5i by negative 5i, and it will be negative 25 I power 2. And we know that I power 2 here equals negative 1, so negative 1 multiplied by negative 25, it's positive 25, so it's 9 plus 25 here, and the final answer will be 34. Here also I power 2, it's negative 1. Negative 1 multiplied negative 4, it's 4, positive 4. Positive 4 plus 25, it's 29. Okay, let's move also to another example, which is division, divided. What about divided? Divided is something special because we have a denominator. The denominator will be a complex number, of course, and we will multiply numerator and denominator by the conjugate. So let's move to the first example for us. If we have an example like that and we want to simplify it, 10 over 3 plus I, and we would like to simplify this form, so we must multiply numerator and denominator by the conjugate of the denominator. The conjugate of denominator makes the denominator here is a real number only. Let's see 3 minus I and also 3 minus I. It like multiplying by 1. So if we multiply denominator by denominator here, we know that this number is conjugate to this number. So directly will multiply 3 by 3 equals 9. I multiplied negative I equal negative I power 2, and multiplied 10 by 3 minus I. 10 multiplied by 3 equals 30, and 10 multiplied by negative I equal negative 10I. Look carefully to the denominator now. I power 2 means negative 1. So 9 minus negative 1, it's 9 plus 1. And this part as it is 30 minus 10I. We have here the denominator equals 10 and numerator equals 30 minus 10I. If you want to divide it, to simplify it carefully, we divide 30 by 10 equals 3, and 10 divided by 10 equals 1I. So the final answer here is 3 minus I. What about the second example for us? If we have 3 plus 2I over 2 minus 5I, and we want to simplify this expression, so we will multiply each numerator and denominator by what? By the conjugate of the denominator, not numerator. Why? Because we have a problem with denominator here, because the definition of complex number, it's a plus bi, it's not 1 over a plus bi. So because the definition here is a plus bi, so we simplify this fraction to be in this form, which is a plus bi, which is the simplest form to a complex number. So we have multiply by the conjugate of the denominator here. The conjugate of 2 minus 5I is 2 plus 5I over 2 plus 5I is something like multiplying by 1. It does not affect the number. Okay, here if we multiply denominator by denominator, they are conjugates, as we said. We multiply the first by the first, it's 4, and second by second, it's negative 25. I times I here is I power 2. Okay, here 3 plus 2I multiplied by 2 plus 5I. 3 multiplied by 2 equals 6. 3 multiplied by 5I equals 15I, and 2I multiplied by 2 equals positive 4I. Finally, 2I multiplied by 5I equals 10I power 2. We will simplify it now. We have 4 minus 25I power 2. We know that I power 2 here means negative 1. So negative 25 multiplied by negative 1 equals positive 25. Positive 25, if we add it to 4, it will be 29. And also here, 6 as it is, we have 15i plus 4i, it will be 19i. And I power 2 means negative 1 here. Negative 1 times 10 equal negative 10. Okay. So we have 6 minus 10 equals negative 4 plus 19i over 29. Okay. And we have divide the first number here over the first. So it's negative 4 over 29 plus 19 over 29i, and this number expresses, of course, about complex numbers because it is as a plus bi. A here is negative 4 over 29 plus b means 19 over 29i. So it's now is the simplest form. Let's move to another example. We have many examples for you to practice, and it's easy for you to calculate and to solve these equations. Okay, simplify also the number 3 example. If we have 2 plus I multiplied by 1 minus I over 1 plus I multiplied by 3 minus 2I. Here is an example, something complex or complicated, because we have to multiply numerator by numerator and denominator by denominator also. 2 multiply 1 equals 2. 2 multiply negative I equals x, it's equal negative 2I. I multiplied 1 is I. I multiplies negative I, it's negative I power 2. Here 1 multiplied 3 minus 2I, it's 3 minus 2I itself. And I multiplies 3, it's 3I. I multiplied negative 2I equals positive 2I power 2. We need to simplify it because I power 2 here, it's negative 1. So we can write 2. Negative 2I plus 1I is negative I. And negative multiplied by negative 1, it's positive 1. Over 3 here. And I power 2 here is negative 1 also. Negative 1 multiplied by 2 equal negative 2. So negative 2 plus 3 equals 1. And negative 2I plus 3I is 1I. Here, numerator we have 2 plus 1, it's real numbers. So we can add them, 3 minus I over 1 plus I. Now we must multiply numerator and denominator by the conjugate of the denominator. So we will multiply 1 plus I by 1 minus I and also 1 minus I. So it's equal 1 multiplied by 1, it's 1. I multiplied by negative I equals negative I power 2. And 3 multiplied by 1 equals 3. 3 multiplied by negative I equal negative 3I. Negative I multiplied by 1 equal negative I. Negative I multiplied by negative I equal positive I power 2. We know that I power 2 here is negative 1. So 3 minus 1 is 2. Negative 3I minus 1I equal negative 4I. And here we know that I power 2 equal negative 1 also. So 1 minus negative 1 equals 2. And we can divide 2 by 2 equals 1. And negative 4 by 2 equal negative 2i. So 1 plus 1 minus 2i is the simplest form because it is in the form of a plus bi. A is 1 and b is negative 2. Okay. Okay. We have also an example. If we have x equals 7 minus I and over 2 minus I, y equals 13 minus I over 4 plus I, and we want to find solve the equation, prove that x and y are conjugates. We want to prove that x and y are conjugates. Okay. Here, if we have 7 minus I over 2 minus I, we will multiply numerator and denominator by the conjugate of denominator here, which is 2 plus I over 2 plus I. Okay. And we will multiply numerator, which is 13 minus I, by the conjugate of the denominator of 4 plus I. So the conjugate is 4 minus I over 4 minus I. When we multiply this number by this number, we will get x equals 3 plus I. And when we multiply this number by this number, we will get y equals 3 minus I. So we have proved that x and y are conjugates because 3 plus I is the conjugate number of 3 minus I. Okay, my dear students, we have finished our lesson for today. Until we meet again, we congratulate you, and please stay home and study well. Goodbye and good luck.